Hi.
And welcome.
Welcome.
Welcome to Earth.
Good day.
Welcome to the big show.
Hey, what's up guys? It's Mr. A again, and today we're going to take a look at the next conic section in 10.4, which is an ellipse. Here's a homework. Go ahead and pause and write that down. So taking a look at conic sections, we're almost there, almost done, and the next thing that we're looking at is going to be the ellipse, which if you remember is when we take, just like this one right here, a two-dimensional plane and cut it through the cone so that it comes out the other side of the cone and not out the base. Here's an example of a pretty decent ellipse. Looks like some sort of a mirror that goes on a boat and attaches to the side somehow, kind of weird. Here's another one, an elliptical table. It's a pretty good ellipse on top there, not bad. This one I kind of chuckled a bit. They said that this one was an elliptical pool. But if you noticed, the difference between the other two ellipses is that the sides are a little bit straight, unlike a regular ellipse. They also call this an elliptical building. Looks pretty good, not bad. And then remember what we were talking about also in class was that the ellipse is also the shape of the Earth's orbit around the Sun. As you can see here, the Sun is a little bit closer to one end of the ellipse than the other. And we'll talk a little bit more about that and what some of those points are. And this is a famous ellipse. It's called the ellipse. And as you can see, this almost the smallest building on the block right there is the White House. So he's got plenty of room to play football, soccer, whatever he wants. It's kind of pretty. Okay, let's take a look at the first ellipse. Now, if you look at some of these important points, what you're going to see is that the ellipse ends here and here at 4, and also here and here at the 2's. Now you might be able to look at that and say, okay, well then the center is obviously right here at 0, 0. Now can you tell me something about those points and the actual equation? Well, to me it looks like the square root of 16 is 4, like here, and then the square root of, oops, messed that one up, square root of 4 is going to be 2. Okay, so that's pretty good. That tells us a little bit of something about an ellipse. Here's another one. And let's see if you can find some of the important points here. Well, I've got 2's. And again, that's square root of 4. And then up here you can't see it, but that's a 5. So I've got square root of 25 is 5. And I don't know if you noticed on the last one too, but just like here, we have the 4 underneath the x. And look at where the 2's are. The 2's are along that that horizontal x directional axis. And then when we take the square root of 25, you can see that we move 5 units away from the center up or down along that y-axis. And the 25 is tied to the y. So that's something important that we're going to come back to. Here's another one. And you're going to see the same things popping up. And I'll give you a clue. There's the center of the ellipse. The ellipse has a center just like a circle. And if you take a look, I don't know if you can tell that this point is roughly, if I drew it right, it's 2, -1. And oh yeah, wouldn't you know it, there it is. I got a 2, -2. This is just like a circle or a parabola, the x minus h and y plus k. And then here's a 1 and a -1. So we're taking those opposites to find the center. And then you can also see too that we've got the 9. So the square root of 9 is 3, and it looks like from the center out to the edge, that's a total of 3 units. And again, it's along that x directional axis. So all pretty important stuff. And then you can also tell the same thing about the 1. Square root of 1 is 1, and we're moving 1 unit in that y direction away from the center. So that tells us a lot about these graphs. Let's keep going and see what we can find. Okay. Here's some of the properties of an ellipse that you guys should know. So for example, let's start with where you would start graphing one here at the center. Okay, the center is this point, and these axes that you see, these little dotted axes, these could be the x or y axis, or it could even be just these axes that cut the ellipse in two, and you notice that the ellipse is symmetrical. So these are like symmetrical axes that when you slice this ellipse through the center, it's going to give you two symmetrical sides of this ellipse. So I'll label this one C for center. Okay? And then we've got vertices. And the vertices are the edge of the ellipse. I'll put V for vertices. They're the edge of the ellipse at basically at the long end of the ellipse. So you can see that this is the long end of the ellipse, both here, and those edges are called vertices, and so they're always along that long axis. Well, then we also have the other edges up top and down below. You see that those are on the short axis, and those are called co-vertices, so I'll put CV for co-vertices. And then, like we were talking about the axis, well, the major axis is, obviously, it's the major one, it's the big one. And that major axis has the vertices on them. And they also have another important point on them called the foci, which we'll talk about in a couple minutes here. Then you got the minor axis, which is, of course, this minor one, the small one that has the co-vertices on it. And the major and minor axis don't always go, for example, the major axis here is horizontal. It's not always like that. For example, in this other graph, you notice that in this one, the major axis goes vertically, and then the minor axis goes horizontally. So let's get back to the properties of the ellipse. You're going to see here that the last one that we have is the foci, and those are these special points that are out towards the vertices. Maybe here and here, and I'll label them F for foci. So 1 is a focus and 2 is foci. I've heard people say foci before. I'll go with foci just because I want to. And let's see. Here's the special property of the ellipse that makes it like a special figure. Pick any point on the ellipse, any point you want actually on the ellipse. I'm going to go with this one right here. And if I draw a line from the foci to that point, and then from that point to the other focus, let me call this distance 1 and distance 2. Well, if I add those together, if I add distance 1 and distance 2, it's just going to equal some number, some constant. Okay? Now pick any other point on the ellipse. Let's make it maybe right here. So it's kind of different than the one that we just looked at. And if we go ahead and do the same thing, if we draw a line, I kind of messed that up, but you get the point. If I draw a line to each focus, I'm going to get another 2 sets of distances. And I'll call them D1 and D2 as well, because you know what? When I add those 2 distances, I get the same constant that I got before. So that's the crazy part, is that no matter where you draw that point, the sum of the distances to each focus is going to be a steady constant all the way around the ellipse. So pretty crazy. So just like we looked at earlier, here's the general form of an ellipse. Okay? You can see that, again, we've also got, get my pen to work, we got H and we got K. And just like every other conic, that's going to give me my center. Center at HK. And then I can find the foci, those special points, by looking at this equation right here. C squared is A squared minus B squared, where the foci are C units away from the center. Okay? So whatever C is, I move that many units away from the center along that big axis. Alright? So that's it for this one. We'll continue it in part 2 and get a couple of examples under our belt, and we'll see you then.